Okay, we're just here looking at solving linear equations in one variable. So one variable basically just means one unknown. Okay, we'll be looking in future at with more than one variable. So just important to kind of recap on a couple of basics. An equation, like the idea of an equation, we take it for granted sometimes that people understand what it is. An equation is based around the idea of equality. So when you have an equal sign, it's telling you something, it's jumping up and down and saying, listen, this sign means something. It's really important in maths. Whatever is on the left hand side of the equal sign is equal to whatever is on the right hand side. It's a huge thing. So for example, 4 multiplied by 2 equals 8. Okay, and we know that from our previous schooling. We know this is true. What about 3b equals 12? Okay, and again, we're told this is an equation because it has an equal sign in it. It's telling us that 3 and 3b basically means 3 multiplied by b. There's a hidden multiply sign that we don't write in these situations. You can put it in, but it's normally not there. We're being told that 3 times some number equals 12. Okay, so if we're asked to solve this equation, we've been asked to figure out what number is hidden behind that b, so that when we multiply that number by b, we'll get an answer of 12. We know that this is a straightforward enough one. We know that the answer is 4 because 3 multiplied by 4 is 12. So we have solved the equation. Basically b equals 4. So if once we've solved that, what we're really doing is we don't need the b there anymore. We can just put 3 times 4 equals 12. Sorted. So variables are there kind of we basically have to figure out what number is hidden behind them. And again, in future, we'll do situations where there might be more than one answer that will make the equation true. So we can easily solve this one in our heads, but what we really need to do is to come up with a strategy that works out in every case. Okay, so a strategy we've outlined a little bit here. So basically, if we have 3b equals 12, what did we actually do in our heads? Some of us just knew 3 times 4 is 12. Other people took the 12 and divided it by 3 and you got 4. Okay, that's the strategy that we're going to kind of take on and use for the equations here. So basically, when we had 3b equals 12, we divided both sides by 3, because anytime you have an equation, another fundamental rule in maths is that you basically have to treat both sides equally, like a balance that you've probably seen before. We can't make a change to one side without making the same change to the other side. Okay, so we divide both sides by 3. You end up then with b equals 4. Ultimately, you're trying to finish off by saying the unknown variable, b or x or y or z or whatever, equals some number. So b equals 4. We have solved this equation. As equations get more complex, we need a strategy. So we're just going to do a more complex example here, and we're just going to walk through how you go about solving that. So we have 4x plus 3 equals 13 minus x. So yes, you can absolutely start saying, okay, God, if I put 1 in there, would that give me an answer? Would that fit? Okay, if I put 2 in there, would that fit, and so on. But what we really, as I said, we want to, rather than having to use trial and improvement or trial and error, we want to have a strategy that will work in easy, complicated, medium, hard, whatever we want to call it, different strategies, different situations. So the number one thing we want to do basically is say, okay, I need, like the previous example, I end up with b on its own equal to a number. So with x here, I ultimately, at the very end of all this, I want x equals something. Okay, I don't know what that is, but ultimately my very last line will be x equals something. So to do that, I need to get all the x's together, and then anything that isn't an x, move it away. So we move it away by putting it on, getting it on the other side. Okay, so this will help us end up with x equals something. Okay, so we start off with saying, okay, we have 4x plus 3 equals 13 minus x. Now it doesn't matter which side, because equality means left equals right, right equals left. But in this case, we'll just say, okay, we'll try and get all the x's on the left. To do that, we have to look at how these numbers are connected. So the 4x is fine. That x is on the left hand side already. The minus x, so the minus x over on the right hand side, we want to move that. All right, the 4x is fine, it's in the right place. We want to move the minus x. We move the minus x by carrying out what's called an inverse operation. So the inverse operation of minus is plus. Okay, so we're going to add an x again to both sides. So again, you can do it write it out a number of different ways. We're basically just going to add x to both sides. Why would we do that? Well, 13 minus x plus x is going to leave us with 13. On the other side, we have 4x plus 3 is 5x plus 3. So the effect of adding x to both sides is it has removed minus x from the right hand side, and it has managed to get its way over to the left hand side. So we have 5x plus 3 equals 13. So we reassess the equation again. So every time we make a change, we look and say, okay, right, what do I need to do next? Now I have the x's all on the one side, but now I have a plus 3 on the left hand side. And ultimately, as I said, we just need x on its own. So we need to somehow eliminate that minus at that plus 3 or move it. And again, we look, it's being added, plus 3. So again, we're going to do the inverse operation of plus 3, which is minus 3. And again, we have to treat it. We do the same thing to both sides. So we end up with 5x plus 3 minus 3. They have eliminated each other. 13 minus 3 is 10. So now we have 5x equals 10. So again, think back, we want to get x on its own. So the last number we have is the 5. So we need to do something about the 5. How is the 5 and what's the connection between the 5 and the x? The connection between the 5 and the x is multiplication. 5x means 5 multiplied by x. So to break that connection, you do the inverse operation, which, as we know, is division. Okay, so I'll just write it out separately here so we don't get confused with different steps. So we're going to divide both sides by the number attached to the x. So that end gives us x equals 2. Okay, so we have solved the equation. Now the question is, how do I know I'm right? How do I know we've solved it? An important part of these questions is that you have the opportunity, and you should do this, to verify your answer. Verify. So you verify your answer by taking what you think is the correct answer, 2, the solution, and put it back in wherever x was. So we'll just write it out. 4x plus 3 equals 13 minus x. So to verify if x equals 2 is correct, we're going to let x equals 2. Okay, so that's 4 times 2 plus 3. It's always good to use brackets, minus 2. Brackets again means multiply without the multiply sign. So we've taken out the x's anywhere we've had them, and we put in 2 and say, okay, if this is true, if this is a solution, well then the left hand side of this equation will be equal to the right hand side. So we have 4 times 2 plus 3. Does that equal to 11? Yes. Okay, so we have verified our answer. So basically we have found the correct solution. When you're doing these questions, it's a really good habit to get into, to verify your answer. Because ultimately, if it doesn't fit back in, well then it is not a solution to this equation. Okay.